Have you ever stopped and wondered what the real difference is between a simple machine and a truly intelligent one? Well, today, we're going to dive into the incredible breakthrough that's teaching robots not just to do things, but to actually think about them first.
It really all boils down to a pretty simple question. What's the fundamental difference between a big robotic arm on a factory floor and your own arm as you reach for a cup of coffee? And trust me, the answer is way more interesting than just metal versus flesh and bone.
It's all about the software. You see, a traditional robot arm is basically a puppet. It's just following a rigid, pre-written script, line by line. A human arm, though, it's constantly adapting, learning from mistakes, and kind of thinking through its next move. And that adaptability, that has been the holy grail for robotics for decades.
So to really understand how we got to this incredible point, we've got to look back at the historical challenge. How in the world do you turn a rigid tool into something that can actually think?
For the longest time, robot intelligence was built like a clunky old assembly line. You'd have one system for vision, a completely separate system for understanding language, and then a third one just for controlling movement. They were all siloed, totally inefficient, and they just could not handle new situations.
But then everything changed. A new foundational innovation came along that finally connected all the dots. It's called the Vision Language Action Model.
And a VLA model is pretty much exactly what it sounds like. It's a single, unified AI brain that merges vision, language, and action into one seamless process. So it's not an assembly line anymore, right? It's one integrated brain that can see the world, understand what we want, and then act on it.
And the process itself is just beautiful in its simplicity. So first, the VLA model sees the world through its cameras. Second, it understands a command you give it in plain English, like, hey, pick up the blue box. And third, it does it by generating the super precise motor commands to make it happen.
Now, VLA models were a massive leap forward, no doubt. But as researchers tried to make them even smarter by getting them to think before acting, they ran into this deep, fundamental problem. It turns out the very nature of thinking was clashing with the nature of acting.
And this is where we get to the really cool cutting-edge stuff. A brand new model called DeepThink VLA was designed specifically to solve this conflict and create a robot that can genuinely, truly think before it acts.
Okay, check out this analogy, because it really gets to the heart of the problem. The AI's reasoning, its internal thought process, is like telling a story. It unfolds sequentially, one word at a time. But a robot's physical action? That's more like playing a chord on a piano. Everything has to happen all at once in parallel. Trying to force one system to do both of those things was absolutely crippling performance.
So the solution is just brilliant. DeepThink VLA introduces something called a hybrid attention decoder. The easiest way to think about it is like a gearbox in a car. It operates in one mode, first gear, for slow, careful, sequential thinking. But then when it's time to act, it shifts gears into a second mode for fast, parallel, coordinated action. And the results? Whoa, they really speak for themselves. Just by putting in this hybrid architecture, this gearbox, the task success rate jumped by over 15 percentage points compared to a standard design. That is not a small tweak, folks. That is a massive, massive leap in capability. And it gets even better. With a little more refinement, DeepThink VLA hit a staggering 97% success rate on a really tough robotics benchmark. This set a whole new state of the art, and it proved that solving that think-out conflict was the absolute key.
But hey, numbers only tell part of the story, right? You got to see this in action. The old robot, it fails to grab something and just gets stuck, repeating the same mistake over and over. Now, DeepThink VLA, it also fails the first time, but then it thinks. It uses its internal reasoning to say, okay, that didn't work. Restate its goal, correct its approach, and nail the task. That is resilience. That is intelligence.
Okay, so this isn't just some science project stuck in a lab. The principles behind this breakthrough are already reshaping our world, right now, in 2026. Let's take a look at how this is moving from the lab into the real world. I mean, just look at this timeline. The pace of innovation has been absolutely explosive. We went from foundational models just a few years ago through these huge phases of scaling and specialization, and now we're in this new era of generalization and safety, with models like NVIDIA's GRO-OTN1 really leading the way.
So in our factories, we're seeing robots like Boston Dynamics' Atlas, powered by Google's foundation models, and they're not just doing simple repetitive stuff anymore. They're handling complex materials. Even FedEx is using AI to unload messy, chaotic shipping trailers, a job that people thought was basically impossible for a robot.
And it's not just in factories. It's also starting to come into our homes. Humanoid robots like 1X's Neo are already making deliveries and learning how to do household chores just by watching people. And you know, when major players like Tesla start putting their humanoid robots to work in their own facilities, that's a huge sign that broader use is right around the corner.
And if you thought that was cool, get this. This technology is even being used off-world. NASA's Perseverance rover on Mars is now using a custom AI to look at the terrain data and plan its own routes. And before that rover moves an inch, NASA checks the AI's plan on a perfect digital twin of the rover back here on Earth. I mean, how incredible is that?
So what's the big picture here? Where's all of this heading? Well, when you put all these technologies together, it really starts to point toward a future that isn't just automated, but is actually self-sustaining.
You know, this whole revolution is really standing on 4 key pillars. You've got agentic AI, which lets robots tackle complex goals all by themselves. You've got VLA models, which let them understand our world. And then you have these amazing advances like wireless power and on-device edge intelligence that are making these systems truly independent, operating 24/7.
And this all builds to what I think is the most important takeaway of all. We are moving beyond robots that are just autonomous, able to do a task alone, to systems that are self-sustaining. We're talking about robots that can charge themselves, do their own repairs, maybe even clean themselves, all without any of us needing to intervene.
And that, of course, brings us to our final big question. As we step into this new era of self-sustaining robotics, where machines can not only work for us but also take care of themselves, we really have to start asking what new roles, what new challenges, and what amazing new opportunities are going to be left for us.